Question 1 asks you to determine the following limits. If you answer positive or negative infinity, briefly explain your thinking and print your final answer in the box provided. So this is going to be really important. If you suspect that the limit equals positive or negative infinity, we're going to have to provide some kind of written justification for that, and I'm going to show you how to do that to get a full credit solution. So the first limit says the limit as x approaches 2 of this quadratic function. So the first thing we want to do when we have a limit is we always want to try to sort of eyeball it and see if direct substitution is going to work. And if it does, then we're done with the problem. So a polynomial, there are no domain issues. The domain is all real numbers. So if we try to plug 2 directly into this equation, we're going to get 3 times 2 squared plus 7 times 2 minus 5. This is going to be 3 times 4, which is 12, plus 14 minus 5, and that works out to be 21. So don't forget on the exam, you want to make sure you're putting your final answer in the box as instructed. This next limit is a rational expression, and it says the limit as x approaches 1 from the left of 2x over x minus 1. So if I try direct substitution here, I'm going to get 2 over 0. So this cannot be the answer to the limit because this is actually an indeterminate form, right? We can't have 0 in the denominator. So this is going to be an indication that we're probably in plus or minus infinity territory. So one thing that's important to keep in mind with limits, what we're actually saying here is that the limit of the numerator is approaching 2 and the limit of the denominator is approaching 0. So the denominator is not actually equal to 0 because we're picking numbers very, very close to 1 on the left-hand side. So we have to figure out here what type of 0 do we have. It's either a very tiny negative thing or a very tiny positive thing. So x minus 1 is approaching 0, and if I pick a number just to the left of 1, like 1.99, and I look at the denominator, well, 1.99 minus 1 is going to give me a negative number. So these are very tiny negative things. So we can say the denominator is approaching 0 and is negative. So if I look back at the structure here, I see I have a positive 2 divided by a very small negative number. So that's how I know it's going to be negative infinity as opposed to positive infinity. So I'm writing the answers here and here just for completion, but you don't have to actually write the 21 here. You could have written it here. We could have written the negative infinity here. But for these types of limits, it's technically incorrect to leave it like this if you don't have some kind of justification. So I think it's a good idea just to write it here and then copy your answer down below. Part C says the limit as x goes to infinity of ln of 5x over x cubed plus 1. So if we try to do direct substitution here, we're going to see that we get infinity in the numerator and we're also getting infinity in the denominator. This is an indeterminate form of infinity over infinity. So this is a great candidate for L'Hopital. If you want to use L'Hopital to evaluate a limit on the final, you have to call out what indeterminate form you have and you have to justify your usage of L'Hopital. So an easy way to do that, there's me calling out the indeterminate form. And when I write the equal sign, I just throw a little LH over it. And that just lets the person know who's grading that when I went from this step to this step, I'm about to do L'Hopital because it's going to make the limit look dramatically different. So we still have the limit as x goes to infinity. The derivative of the numerator is 5 over 5x, so it's 1 over 5x, and then the chain rule says do it times 5. The derivative of the denominator is just 3x squared. So I'm going to clean this up a little bit. Notice I'm not putting an LH over this step because I'm not taking another derivative. I'm just doing algebra here. So when you have a fraction, right, divided by a fraction, we can multiply by the reciprocal. So I have 5 over 5x times 1 over 3x squared. I'm going to take this out one more step just to clean it up a little bit. And I can see here that my 5's cancel. And now all I need to do is evaluate the limit of 1 over 3x cubed. And this limit is going to be 0 as x goes to infinity. So my final answer is 0. So one thing I want to make a comment about this problem, make sure if you're having to do some algebra steps along the way that you're not dropping the limit notation too early. You're not allowed to drop the limit until you're actually evaluating the limit. So all we're doing along the way here is preparing to evaluate this limit. Make sure when you write the limit that you're using the proper notation, and if you check your penalty sheet, you'll see that improper notation can cost you up to 20% of the total points for the problem.